Something called logarithmic and exponential forms, two different forms. We're going to go back and forth. We're going to be putting things in exponential form and then switching it back to log form and vice versa, because sometimes one form is easier to solve equations than other forms, right? Now, back in the day when I had to do things, we didn't even have what you call there's handy dandy calculators, right? Yeah, didn't have them. In fact, if you did, I remember the Casios. It was like the teacher would say, "Hey, get these like little four function Casios. They're only like $50." I'm dead serious. And so we didn't have calculators, and we had slide rules. Okay. However, your handy dandy calculators, as nice as they are, yes, they added slide rule. So, if you notice, even as advanced as you guys are, because you're way more advanced than me, if you look at your calculator, you only have two what we call log keys here, and logs have a base. Okay, I'm going to write it out, and guys, I'm going to be writing in what we call cursive writing because that's what I did for 30 years. Okay, so I write log like that. Okay. Now you guys are probably gonna write it, and this is actually I have to think, and it's hard for me. You guys probably print it, right? Log. Okay. So, but since I did this for more than I probably have to say closer to 40 years. I'm gonna be yeah I know I'm gonna be writing it like that, and it's gonna be log of x. This is the common, uh, okay, and our base here. I'll put an X here for you printables. Our base goes here, okay, and common log has a base of 10. So just like exponents, like the first power, 3 to the first power, we normally don't put the 1 there, right? It's the same thing with log base 10. We normally don't put log base 10 in there. We just say, hey, log of x. And for you printable people, which is probably all of you, I can't even write the G. I can't even print it. It's cursive. Log of x.
Sound, sound like you don't like printing things.
It's not that I don't like it. It's very hard for me to do because I have to actually think about printing.
Oh.
You know what I'm saying? All right, natural log. Okay, natural log is going to be log of x, but my base is e. And you printing people, you printing normal people. Let's see if I can do a print a G, just like that, right? I don't even know how to do it. Okay, so log base e of x. Now this time we're gonna we're gonna not use the word log. We're gonna use ln. Yeah, ln of x. And for you guys, it's probably ln of x. Okay. So we for natural log, there's a base e there. Again, we just normally don't put it right. We'll just say natural log of x. Did I confuse everybody with my cursive and printing? Okay, so log form. Log form, I'm going to have my log, and I'll try to start out with printing. So I have my log, my base b, right? That's my base. And when you guys put the base in there, kind of it's a subscript, so kind of lower it a little bit if you can. I know it's not the easiest thing to do. And then, so we're going to have log with a base. Remember, if it's base 10, we don't put it there, or if it's base E, we use ln. Okay. Of a number. Um, I'm going to, I don't even know how to print it in. I think that's it.
Yeah, that's pretty correct.
Okay, so that's our number. And that's going to equal A, and A is going to be the exponent. Now, sometimes we like to have things in log form. Other times we have to like things in exponential forms. One may be easier to solve than the other. Now, just like addition or subtraction undoes addition, multiplication undoes, I'm sorry, division undoes multiplication, right? Exponential form kind of undoes log form, and log form undoes exponential form. Just think of it that way. Okay. Now, exponential form, you guys know this because you've been dealing with it for 2 years of algebra. We have our b base, right? That's raised to our a exponent. And that equals our number. So, like 3 squared equals 9, right? So, 9 would be our number. So, now that we have our two different forms, we can go back and forth. Write them, if they give it to us in log form, we can write it in exponential form. If they give it to us in exponential form, we can write it in log form. So, let's do that. So, here, they give it to us in log form. 4 is going to be my base, right? So 4 is my base. My exponent, 16, right? This is my A. So 16, that equals my number, which is x. So that's exponent form, that's log form. Pretty easy, right? Okay, remember, in our natural log, it does have a base there. We just normally don't put it, right? E. So my base is E raised to my exponent, which is A, right? That's my exponent. A equals my number 5. Okay, let's go the other way. So 5 is my base. X is my exponent A. And Y is my number, right? So I'm going to write log. My base is 5. Careful. My number goes next, right? Which is Y equals my exponent X. Yeah, not too bad. You got to be careful because, especially when they throw in X's and Y's, and you know, they'll do that, and sometimes it does get confusing. It even confuses me sometimes, which is hard to do. Um, when they start throwing in x's and y's in the same problem. Okay, so 10 is my base, 3 is my exponent a, and then x plus 1 is my number. So I have log, and my base is 10. Now, you don't have to put 10 there, but I'm going to do it just because for teaching purposes. My number, x plus 1, I better put it in parentheses, x plus 1, that's going to equal my exponent 3. Oh,
Sounds like you're in the hall.
my phone's ringing. That's an iPhone, isn't it? Okay, so I'm going to have you guys do this without a calculator the way I used to do it. Evaluate them, right?
Like, like what we just did.
Without a calculator. Well, here we were going back and forth between the forms, right? We're actually going to evaluate some logarithm equations. So I should make this an equation. We don't know what this equals. Just going to put a question mark there. Our job is to find out what the question mark is, right? Okay, so I'm going to put it in an exponential form because we've done exponents, right? For many, many years. So my base is 3. Let's see, my exponent. There's my a, right? That's my a. So it's my question mark. That's what we have to find out. Equals, and my number is 81. Now, this is where that little handy dandy chart's going to come into play. A lot of these numbers are small enough that we can use our little chart. And somebody had this all filled out. I can't remember. Was it you, Kelina? Yeah, she filled out the rest of these, which would probably be pretty helpful for you guys. So I'm looking here. Well, 3 to what power equals 81? So I'm looking for 3. And then I'm going to go across. Here's 81. So 3 to the 4th. So my question mark equals 4. That's my answer. 4.
Oh, so that's what we have to do, basically.
Mm-hmm. All right, next one. And actually, this one's pretty easy because my base here is 5, right? And again, I don't know. I'm going to put my equal because it seems like they didn't finish it for us. Okay, so 5 to what power equals 1?
I guess.
0. Who said 0? Keith? Yeah, any number raised to the 0 power is 1. So it's got to be 0. Right? Well, that was pretty easy. Okay, my base 4 to what power is going to equal the number. Now, it happens to be 4, the same. 1. Now, that's easy. You don't think they're all going to be that easy, do you? No. Next one. Yeah, kind of throwing a wrench into things, right? Our base is 1/2 raised to what power equals 8? Any ideas whatsoever? 16? Does it work? 1/2 raised to the 16th is 8. Well, let's try it.
4 divided by 2, I guess, for the square.
Remember, exponential stuff we can put in the calculator, right? Let's try it.
I was
1/2 raised to the 16th. At decimal, I'm going to change it to a fraction. Hit math, enter, enter.
Wait, we're not supposed to use our calculator.
No, doesn't work anyway.
You're a cheater.
Yeah, I was just checking my answer. You know,
And
16. 16 is not the answer, right? Well, is there any way I can raise the 1 to anything to get 8? There really isn't. There isn't any way I can get that 1 to be an 8, is there? Raising it to a power. Because no matter what power I raise 1 to, it's always going to be 1. How about let's look at the 2. Let's look at the 2. Is there any way to get 2 raised to a power to get 8?
yeah,
And what power?
4. Not 4.
Careful. 3, right? So if I can get 2 to the cube, 2 cube equals 8. Well, let's put a 3 there just to see what happens. So if I have 1/2 raised to the 3, it gives me 1 to the 3, 2 to the 3, right? Which equals 1/8. Man, I'm really close, right? 8 and 1/8. In fact, they're reciprocals of each other. How can I flip it? How can I make? How can I flip it with that exponent? Negative. Negative 3. Right? If this was negative 3, so this would be negative 3, then it would be 8 over 1. So in this problem, my answer is negative 3. Pretty tricky, huh? That's some tricky stuff going on. Thankfully, I had enough coffee this morning to do it. All right, now, oh boy, we get to use our calculators, don't we? Let's use technology. Hopefully, I got my 2 keys here. My common log key. Move this up.
The screen is pretty hard to see. Oh, there.
So I have my common log key base 10 and my natural log base E, right? So this is my common. They want us to find common log of 5. So all I have to do here is hit common log 5, enter. I have 0.69. Let's go 3 decimal places. 0.699. And you guys don't even have to use a slide rule. Next one, this time it says take the natural log, so it's the ln key of 5. And I get 1.6609. So which way do you think is easier, guys? Yeah, of course.
Well,
But
without the calculator.
unfortunate, we can't put in log base 3 in our calculator, can we? How? Oh, wait, you guys got new software. You can do it. That's cheating.
Uh-huh. Wait, I don't know how to do it.
Yeah, I
So
did.
we're not going to show you how to do it.
Yeah, we're not going to show you. I know.
You'll be fine typing it out.
Yeah, yeah. I don't like that.
My only problem with
I don't like that whole student discovering things. That's it's bad for my evaluation.
Have you ever done that before in your own classes?
What's that?
Have you ever done discovering the tricks in your high school years?
Like I said, we didn't even have calculators, so it was hard to discover. It was very difficult when we discovered a lot more patterns than you guys do today because we had to. Those were our shortcuts. All right, so let's do a little science project here because you guys are always complaining about, oh, well, when are we going to use this in real life? Well, hey, here's a real life situation here. Suppose you buy this mansion on the beach, right? And you want to change the slope of your beach because maybe it's too far or too angled or maybe not angled enough. So
Yeah. Like I'm
so
never gonna own a mansion.
here's an equation that says, well, the sand particle here on the beach is represented by this equation. S equals 0.149 plus 0.118 times the log of D. Now, this is acting like it's a number times the log. So it's acting like a coefficient almost, right? So find the slope of the beach if the average diameter, so there's my D, right? My average diameter of a sand particle is, hey, this equals 0.25. So all I have to do is substitute that in my little sand particle form equation up there, right? So I have my sand particle S equals 0.149 plus 0.118. I'm going to put parentheses around this because otherwise it's just really hard to distinguish that I'm multiplying here.
So we put this in our calculator.
Log, I would. Log, and I'm going to print it, see how the effort I put into it, printing. Diameter is 0.25. Now, I can put this in my calculator because what's my base? 10, right? There's no base there, so it's a common log. So I got 0.149 plus, now you don't really need parentheses, but I'm going to go ahead and put them in. 0.118 times common log key 0.25. And my new sand particle size is 0.078. See how easy that is with your handy dandy calculator? Was it millimeters? Fascinating, isn't it?
My brain is blown.
Okay. Inverse properties. Guys, remember inverses? Well, we have some properties in logs and exponential form. Okay. What this really says is this is really what's cool about these two properties. If I have the same base number here being raised here, see how I have a B and a B? Log base B of B, guess what I get to do? I get to cancel those out. And what I have is x equal x. Isn't that cool? So log base B of B to the x equals x. It also works in exponential form. B raised to the log base B, guess what? Those cancel out. So I can just end up with x.
Wait, what?
If I have, these are inverse properties. If I have log base B, log base B of a number B to the x, everything cancels out and I'm just left with x. Same thing in exponential form. If I have the base B raised to the log base B to the x, everything cancels out and I'm just left with the x. Okay?
All right, sorry.
They're inverse properties. Okay, it's confusing. So if I look at these, if I have the same base in the log and the base of the number, guess what I get to do? I get to cross them out. My answer is 3. Here I have exponential form, right, raised to a log. So this base, log base 5, cancels out the base 5, and I'm just left with. Now remember, with the natural log, there is a base e there. So my base e here cancels out my natural log, and I'm just left with. Isn't this easy? Okay, let's be a little careful here. Again, we're multiplying. This is acting like a coefficient, right? So I have 5. Now these are going to cancel out because this is a log base e, right? Cancels out my e, but I'm still have 2. Don't forget you have to multiply those together. This is common log base 10. So these cancel out, and I'm left with. All right, inverse. Finding inverses in action. Okay? And I hope you guys remember this. So if I have the equation y equals log, and I'm going to print this, log base b, here's my colored pens, here's my b, of a number x. So there's my equation form. Okay? Y equals log base b of x. Log base b, log b base of x. I forgot even how you say it anymore. You guys remember your inverses? How do we denote it? Y minus 1 is going to equal our exponential form. Base b to the number, this number becomes the exponent. Okay? So that's how you find inverses. You ready? Are you ready? So my inverse is going to equal, let's see, my inverse is going to equal the base, which is 3, and my number is x. So that's my answer. Not so bad, right? My inverse,
Inverse is 10. The base is 10.
good, and the number, my exponent is going to be the number x. Now, these two, they're giving it to us, and we have to put it in that form. So y equals 4 to the x. Oh, sorry. My inverse is going to be log. I suppose I should write down the equation here, right? That would help.
Wait, log? Would that be ln? So log?
I'm sorry? Yeah, this one would be. Hang on, let me get there. Our inverse equals b to the x. I suppose you could have just looked up there. But... Okay, so my base, let's see, goes after the log, right? I need a log. My base is 4, and my number x.
Wait, that's entirely different from the way that you just wrote down.
My y inverse, I have b to the x, right? I'm going this way. So I need to put in a log. There's my log. My base,
You're using the exact
4.
same.
It is.
I'm not even-
I know. I thought it cut off up here. It cut off on my computer screen, so I rewrote it down here. Same equation. So my inverse, you guys could have just looked up there. My inverse equals
LN.
ln this time, right? Because it's natural log. What's my if you want to put the e there, that's fine. Yep.
Alright.
Yeah, I suppose I should have put this first and then this second. That's it for part 1. How do I know the difference? Um, this is common log. I'm sorry, not common log, but the base here is 4. Okay. This has e. E's a natural occurring number in the universe. Okay, it's like pi, kind of. Okay. So to undo e, this is like 2 point something, 2.14 something, yeah. Okay. To undo the base e, we use the natural log. Okay. And if you want, Aiden, you could switch these. Okay. If I start out with,
I'm sorry.
I should have switched them. No, you're right. I should have did this. Y equals b to the x.
I'm just a little
Then
confused
the
at
y
first.
inverse is going to equal log base b
Sorry.
to the x. Okay.
Yeah, I apologize for that. Sir.
No, it's my fault.
I didn't mean to come off as
I should have switched them. Any questions? You guys have the homework sheet? They're really they go quick. Okay, I know there's a lot of problems on there, but I mean,
a lot of that should not pay off.
if you want, I would put the 2 forms on here. Log base 10. Okay, you know those two. I would put these 2 right on your worksheet. These 2, because it's going to take a while to get to know these. This is log form, and then this is going to be exponential form.
We don't have much.
No, we took up quite a bit of time, or I did.
So like this.
So my base is going to be 20.
Yeah.
20 raised to the negative 2 equals 1 over 4.
I'm not gonna look right here, but and this is
3, I'm sorry, 9 to the 1/2 equals 3. Log My base is 19 to the number 361 equals my exponent 2.
Yeah.